Hello everyone from the world of industrial automation. The main goal of this channel is to teach you how to work with CODESYS using real-life examples of automated control systems, not with a virtual PLC, but with an actual controller and other industrial equipment from akYtec. Let's develop an automated control system for an industrial dry heat sterilizer, which is used to disinfect metal instruments, for example, in the medical or beauty industries. Web visualization allows you to control the automated system using any device with a browser, including your smartphone. All the mentioned devices are connected to each other through a router that has internet access. This template, developed by akYtec, frees the user from needing to know what Modbus is. In other words, you don't have to spend time studying documentation, the module's register map, and you won't have to think about how to properly configure numerous parameters to form requests, or rearrange registers to get correct data and convert them to the required types. How did we end up in the middle of the CODESYS project? To answer that question, let's go back to the very beginning. The first step is to download the necessary software. For this, let's go to the akYtec website. In the Products section, select Programmable Logic Controllers. Then choose the SPC210 Touch Programmable Controller. After that, go to the Documentation tab and select Software. Let us know in the comments what other settings you would add to the emulator project, because it's clear that a sterilizer has characteristics like heater power, tank volume, and thermal insulation, and depending on the sterilizer model, all the characteristics I mentioned can be completely different. With prolonged exposure to temperatures above 200 degrees Celsius, the cutting edges of metal instruments can lose their sharpness, and it can also cause the metal to lose its hardness and strength, as well as change its color. We send this alarm to the cloud service of the company akYtec in read and write mode, so that only the operator can reset this alarm after analyzing the abnormal situation and fixing the cause of the sterilizer malfunction. Write in the comments what you would like to see in the surprise section. And who knows, maybe we'll cover your topic. In the next video, we'll take a detailed look at the emulator algorithm code in ST language, and also explain how to set up data transfer between the main project and the emulator project. Let's break down the emulator algorithm. First, let's look at its variables. Emulator operating mode. 0. Initial mode. Simulation of the initial temperature in the sterilizer. 1. Normal mode. Simulation of heating, increasing temperature, and cooling, decreasing temperature, according to the emulator's specified settings. Emulator command for simulating various processes in the sterilizer, for the normal operating mode of the emulator. 1. Simulation of heating, that is, increasing the temperature inside the sterilizer. 2. Simulation of cooling, that is, decreasing the temperature inside the sterilizer. Simulated temperature inside the sterilizer. Heating rate, that is, the rate of temperature increase per second in normal mode. Cooling rate, that is, the rate of temperature decrease per second in normal mode. Main task interval, expressed in seconds, that is, 0.01 corresponds to 10 milliseconds. Analog output control signal. With this, we convert the simulated temperature into a current in the range from 4 to 20 milliamps, where the lower limit of 4 milliamps corresponds to 0 degrees Celsius, and the upper limit of 20 milliamps corresponds to 200 degrees Celsius. The first condition of the case operator. If the emulator is in the initial mode, we set the simulated temperature to a value corresponding to 25 degrees Celsius. The second condition of the case operator. If the emulator is in normal mode, we check the next condition. If the emulator command is set to simulate heating, then on each cycle of the main task, meaning every 10 milliseconds, we increase or simulate the temperature inside the sterilizer according to the specified heating rate. So, with a heating rate of 2 degrees Celsius per second, the simulated temperature will increase by 0.02 degrees Celsius every 10 milliseconds. Next, if the emulator command is set to simulate cooling, then on each cycle of the main task, that is, every 10 milliseconds, we decrease the simulated temperature inside the sterilizer according to the specified cooling rate. If the simulated temperature drops below 25 degrees Celsius, we set the simulated temperature to 25 degrees Celsius. We also reset the sterilizer command to 0 in order to stop the process of changing the temperature inside the sterilizer. The next expression limits the simulated temperature output to stay within the allowed range of 0 to 250 degrees Celsius. But we want to simulate a temperature from 0 to 200 degrees Celsius, so let's adjust this expression. The next expression converts the simulated temperature into a current in the range from 4 to 20 milliamps, where the lower limit of 4 milliamps corresponds to 0 degrees Celsius, and the upper limit of 20 milliamps corresponds to 200 degrees Celsius. We multiply this expression by 1000 because the control signal range for the analog output takes values from 0 to 1000, where 0 corresponds to 4 milliamps and 1000 corresponds to 20 milliamps. With this signal, we can encode the temperature for our range from 0 to 200 degrees Celsius with an accuracy of 0.2 degrees Celsius. But this accuracy for our range can be improved. Write in the comments if you know how to do this, or maybe you want me to show this method in future videos. Write in the comments what the last condition is for and whether it is necessary. Let's move on to the second topic, how to set up interaction between the main project and the emulator project. Now, let's add the analog output module template MU210502 operating in Modbus TCP slave mode to the device Modbus TCP master. In my example, this template has already been added. It allows you to emulate the process of changing the temperature inside the sterilizer. In the Parameters tab, let's set the operating mode for the first analog output to the range from 4 to 20 milliamps. Write in the comments whether we need to configure a safe state for the analog output in case the MU210 502 module loses connection with the SPC210 controller. Now, navigating over to the Input-Output Mapping tab, we are going to establish a link between the analog output control signal variable and the specific channel, output value right. Next, let's make SPC210 a Modbus TCP slave device. To do this, add a Modbus TCP slave device from CODESYS to the Ethernet device. In my project, this has already been done. In the General tab, check the writable box for the holding registers area. Write in the comments what this setting is for. Next, in the Input-Output Mapping tab, we link the emulator command variable to the channel, holding register 0. Now let's go back to our main sterilizer project and add a standard Modbus TCP slave device from CODESYS to the Modbus TCP master device. In the Modbus Channel Slave tab, add a channel to send the command to the emulator. I already have this channel added. In the Name field, enter the name of the emulator command variable. In the Access Type field, select the Write Multiple Registers function, or function code 16, and in the Offset field, specify register 0. Now we can send any commands to the emulator from our main project. For example, a command to heat or cool the sterilizer tank. Write in the comments. How would you change the emulator's algorithm and functionality, taking into account characteristics like the sterilizer's capacity, heater power, and thermal insulation? Let's answer the question from the previous video. What did I forget to add to the device tree compared to the project from the first video? In the previous video, I forgot to add the Modbus TCP slave from CODESYS to the Modbus TCP master device for sending commands to the emulator. And I also forgot to add the symbol configuration for integrating SPC 210 with the akYtec cloud service. Surprise section. Let's add a list of allowed IP addresses in SPC 210 so that only devices with IPs known to us can connect to the web visualization from the internet or the company's local network. To do this, let's go to the controller's web configurator and select the Firewall section under the Network tab. Go to the Custom Rules tab and add two groups of entries. The first group allows access to the web visualization only from the IP addresses we've permitted, using both HTTP and HTTPS protocols. Next, be sure to add two more entries below these, which block access to our web visualization from all other IP addresses. Right now, the IP address entered here doesn't match our computer, so when we go to the Web Visualization tab, it won't display. Let's go ahead and carefully correct that very last digit of the IP address. Once that is done, make sure to save all of your current settings and verify that the network access is fully available to you now. Then, in our very next video together, we will go over the entire equipment connection scheme in detail and continue to improve our projects. Now, I suggest you identify any shortcomings you've noticed and propose ways to address them. We're also looking forward to your suggestions for improving the sterilizer algorithm. For example, you might suggest replacing the temperature control method with a more precise one, such as PID control. Additionally, I offer you a selection of training video topics, which I've pinned on the channel for you to choose from. How can you use the built-in OPC UA server protocol in CODESYS to integrate SPC 210 into popular automation platforms from well-known companies? How can you use the built-in cybersecurity tools in SPC 210 to protect against hacker attacks? How can you increase the response speed of SPC 210 and the I/O modules pulled via the Modbus TCP and Modbus RTU protocols in CODESYS? What are the advantages and disadvantages of the Modbus master and Modbus slave modes of Weintek operator panels when used together with SPC 210? What are the advantages and disadvantages of multitasking in CODESYS? How can you use the visualization editor in CODESYS to create a multilingual project and set up screen navigation? How can you use the built-in Linux utility call library in CODESYS to integrate SPC 210 with popular automation platforms from well-known companies, and in general, with any specialized applications? How can you use the built-in akYtec communication library in CODESYS to bypass the limitations of standard Modbus components? Let us know in the comments which topic interests you most from the ones suggested, or suggest your own. Also, if you want to learn CODESYS on real industrial equipment, our channel has the exclusive right to provide a promo code for a 35% discount on the purchase of SPC 210 and input-output modules from akYtec. To get this promo code, all you need to do is follow the link below to the WhatsApp or Telegram channel, where you'll find my personal contact in the channel profile. You can send me a direct message with the text promo code. But I want to point out that this promo code is only valid for 24 hours. So please contact me only if you've already added products to your cart on the akYtec website. And here's another nice surprise for those viewers who purchase a SPC 210 and send me the serial number of their controller in a private message. I'll provide you with all the CODESYS projects used in our channel's videos for free. You can also subscribe to our WhatsApp and Telegram channels so you don't miss announcements about upcoming videos. And of course, so you can always get a promo code for a discount on akYtec products. And don't forget to subscribe to our YouTube channel so you don't miss future videos. And give this video a like if you enjoyed it. That's all for now. See you in the next videos.